Now let's talk about the exponential function, one of the most important functions in calculus. So an exponential function of base a is written as f of x equals a to the x power. So x is in the exponent here, and we're only considering a to be a positive number. The exponential function satisfies certain arithmetic rules. So a to the x times a to the y is equal to a to the x plus y. A to the x divided by a to the y is equal to a to the x minus y. And a to the x all raised to the y power is equal to a to the x times y. So when you multiply, you add the exponents. When you divide, you subtract the exponents. And when you raise to a power, you multiply the exponents. In calculus, we have a very special base. We have the base with the number, which is called e, Euler's number. So we write f of x equals e to the x. And that's what we call the exponential function. And sometimes we'll give it the name exp of x. Okay, so either way, sometimes I'll write e to the x, and sometimes, like when you're typing notes, you don't want it rising above the line, so you just write exp of x. So what is e? So e we can obtain by a limiting process. So it's the limit as n goes to infinity, so n becomes as large as you like, and then it's this expression 1 plus 1 over n raised to the nth power. And that limit then can be our definition of the number e. So let's just look at this limit for a second. As n goes to infinity, 1 over n goes to 0. So the base here will go towards 1, but we keep raising it to higher and higher powers. So it's not clear what this limit will approach, or even if it approaches a limit. So let's look at a table of numbers to see if we can estimate what the value of e is. So here is our table of numbers. This is the value of n that I'm using. The convergence is relatively slow, so I'm going to go up by factors of 10. So 1, 10, 100, 1,000, etc., down to a million. And then we compute 1 plus 1 over n raised to the nth power. So if n equals 1, then that's just 1 plus 1 raised to the first power, which is 2. Then when n equals 10, it's 1 plus 1/10, or 1.1, raised to the 10th power, and we get 2.59374 with following digits. I'll only show you the first 5 decimal points. And then as we increase n, we see that this number starts to converge, 2.70, 2.71, and then we get 2.718, and then finally we get 2.7182 and 8. And here the number is converged to 5 decimal places. So e is approximately a number 2.71828, etc. It turns out that e is a transcendental number, so that means it's not a root of any polynomial equation with integer coefficients. We'll show you that in calculus, e will be an extremely important number. Okay, so in this video, I introduced the exponential function, the one that we will use in calculus, which is e to the x, or you can write that as exp of x. And e is this limiting expression, the limit as n goes to infinity, 1 plus 1 over n to the nth power, and we see that it's approximately 2.71828. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.